Welcome back, guys. This is now the last segment of the chapter on the digestive system, and we're ready to rock and roll. Take a look at the next one. So, the small intestine. We're now getting into the small intestine and later on the large intestine, and then we're done with the chapter, and then we're going to get into nutrition itself. So, for the intestine itself, take note that part of the intestine is actually like very long, and it's actually made up of three segments: the duodenum, which is actually your purple one, the light blue segment, which is the jejunum, and the light purple end is actually the ileum. So the small intestine is the major organ of digestion and absorption. Okay, it is 2.4 meters long, or about 7 to 13 feet, from the pyloric sphincter all the way to the ileocecal valve, the point at which the intestine will join the large intestine. The small intestine joins the large intestine at the ileocecal valve. And it has a diameter of about 2.4 or 2.5 to 4 centimeters, roughly about 1 inch to about 1.5 inches. Now, it is subdivided into three sectors. You have the duodenum, which is mostly retroperitoneal. It's about 10 inches only in length. It curves around the head of the pancreas. And you have the jejunum, which is roughly 8 feet long. It's attached posteriorly by the mesentery, posteriorly into the dorsal body wall. And the ileum is about 12 feet long, attached posteriorly again by the same mesentery. It joins the large intestine, the ileum joins the large intestine at the ileocecal valve. So, here is our liver showing its relationship to the gallbladder and to the first segment of the intestine, which is the duodenum. Take note that they are very close to one another, and the duodenum, as a matter of fact, is wrapped around the head of the pancreas. So let's take a look at the microscopic anatomy. Now, the small intestine has modification for absorption. Pretty much its length and other structural modification would provide a large surface area for nutrient absorption. And the surface area is increased about 600 times because, which is roughly the size of a tennis court, because of the presence of the villi. And of course, there are still also the microvilli. The villi are supposed to be like convolutions in the folds in the intestinal lumen and the walls of the lumen of the intestine, increasing its surface area 1,000 times fold. And these are the circular folds, in pretty much not only the villi but the circular folds. You have also the villi and the microvilli. The circular folds, and these are actually very prominent as plicae circularis in your duodenum. These are permanent folds. It's about 1 centimeter deep that force the chyme to slowly spiral through the lumen, allowing more time for nutrient to be absorbed. And you have the villi. The villi are small finger-like projections of the mucosa, about 1 millimeter high, with a core that contains dense capillary bed and lymphatic capillary called lacteal for fat absorption. Then finally, you have the microvilli. The microvilli you cannot see here in this picture, but if you're going to enlarge one cell, you'll find out that this one columnar cell has cytoplasmic extensions that give a fuzzy appearance, which we call the brush border because they look like really brush, okay? And they contain membrane-bound enzymes, or the brush border enzymes, that's used for the last stage or the end stage of carbohydrate and protein digestion. So, looking back, okay, so here's a good picture. This picture right here is a picture already of the villi. And then if you're going to be increasing again, if you're going to be magnifying that single square right there or rectangle right there, you will see a single cell and it will have microvilli. The reason why it's called brush border is because it looks like bristles, and that's why you call it brush border. Okay. This is the microvilli of the small intestine. You could just imagine, all right? These are really under electron microscope, and you could see the mucus granules, okay, on top of the microvilli. All right, so let's move on further down in the histology. The modifications of the mucosa and submucosa of the small intestine usually reflect its function in digestion. The intestinal crypts, the tubular glands scattered between the villi, are actually like this particular area right here. You could see that there's a hole right there. And this is actually one example right there. That's actually an intestinal crypt. It's a tubular gland. There are 5 main types of cell that you find right here along the villi and in the crypts itself. You have the enterocytes. Pretty much the enterocytes are pretty much what makes up the bulk of the epithelium. This is actually the pink cells right there. These are your enterocytes. They are absorptive cells. They are simple columnar absorptive cells bound by tight junctions, and they contain many microvilli in them. The function of the enterocytes, okay, will be like in the function of the villi itself. It absorbs nutrients and electrolytes. The crypt itself, they produce intestinal juice. They produce a water mixture of mucus that acts as a barrier fluid for the chyme. So goblet cells, there you go. Those blue, big, like pucks of blue, okay, blue cells are goblet cells. They are mucus-secreting cells found in the epithelia of villi and crypts. And they are called enteroendocrine cells. This one here, let's see. The enteroendocrine cells are the green ones. Can you see that? And they are the source of the enterogastrones and called CCK and secretin. They are found scattered in the villi, but some of them are already in the crypts. I could see the green enterogastrone cells right there. Planet cells, they're found very deep. They're yellow ones, very rare, but you find them there. Found in the deepest part of the crypts. These are specialized secretory cells that fortify the small intestine's defenses. So these are like cousins of your white blood cells. They secrete antimicrobial agents such as defensin and lysozyme, and these substances are or can destroy bacteria. And of course, there are also stem cells that continuously divide to produce other cells. Usually, the villus epithelium is renewed every 2 to 4 days, which is really very fast. So, your intestines, most especially in the part where you have almost already at the distal end of the small intestine, which will be your ileum, they are loaded with mucosa-associated lymphoid tissue, most especially the Peyer's patches, okay, or the malt and the Peyer's patches. They are aggregates of lymphoid nodules. They are located in the lamina propria. They are found in great numbers in the distal end of the small intestine. The lamina propria also contains a large number of plasma cells, and they secrete antibody A. Now, the submucosa of your intestine is made up of areolar connective tissue. There are, of course, also duodenal glands. in the these are mostly present in the duodenum. That's why you call them duodenal glands. The duodenum carries a lot of this because that's pretty much where the acidic chyme would enter from the stomach, right into the duodenum. That's going to be their first step. Therefore, the duodenum is loaded with a lot of glands that produces alkaline mucus to neutralize the acidic chyme. So let's take a look at some clinical imbalances. Now, if a person is on chemotherapy, usually these agents would target rapidly dividing cancer cells. Cancer cells are rapidly dividing, and because the GI tract epithelium is also rapidly dividing, that's one of the negative side effects. Many patients undergoing chemotherapy have symptoms of nausea and vomiting and diarrhea because their epithelium, GI tract epithelium, is also being targeted by chemotherapeutic agents. Now let's take a look at the intestinal juice. The juice that is actually produced daily, about 1 to 2 liters, so in response to pretty much like a distension or irritation of the mucosa. This is a major stimulus. The major stimulus for the production of the intestinal juice will be the entry of your chyme that is rich in food and very acidic, and also slightly alkaline isotonic. They're slightly alkaline with the juice is slightly alkaline with that is slightly an isotonic with a blood plasma. And the mucus in the juice, it carries some mucus in the juice, is secreted by the duodenal glands and the goblet cells of the mucosa itself. So, how does the digestive process go in the small intestine? Well, first of all, chyme, which is very acidic from the stomach, contains already partially digested carbohydrates and most especially proteins, and partially digested or lots of undigested fats. It takes about 3 to 6 hours for food for the chyme to travel through the entire intestine to absorb, to be able to finish the digestion and absorb the digested nutrients, and most of them also water. Now, the enzymes for digestion pretty much are coming from bicarbonate digestive enzymes, which is not really brush border. This is actually imported from the liver and the pancreas. The brush border enzymes are actually the ones that are being produced in the by the cells, the columnar cells itself of the intestine. They're bound to the plasma membrane, performing final digestion of the chyme. So, what regulates the entry of the chyme? Well, chyme entering the duodenum usually is very rich in food, very hypertonic. Therefore, chyme delivery has to be slow to prevent osmotic loss of water from the blood. And low pH of the chyme, which is acidic pH, also needs to be adjusted upwards because the enzymes in the small intestine will not be activated in a very acidic environment. It has to be close to neutral. Chyme has to be mixed with bile and pancreatic juice to continue digestion, most especially of fats. The enterogastric reflex, there is actually an enterogastric reflex, and I showed this already in the previous slide, okay, in the previous, part 2 of the digestive system video. And the enterogastrons would control the movement of food into the duodenum to prevent it from being overwhelmed. So here's pretty much the movements that are involved in the digestive process. Okay, pretty much after a meal. Okay, segmentation is the most common motion of the small intestine. This is your segmentation. Think of these small chambers to be like your dryer. Okay, the dryer of your, when you're washing clothes, you put them in the dryer, the clothes dryer. And you don't expect the clothes dryer just to, blow hot air. you expect the clothes dryer to be spinning, to be mixing the clothes that are already in there. If they are not going to be mixed, you ready for you at the front office? Daniel Carcamo, please come to the front office. My apologies. That was actually an announcement, and I thought something is wrong already. I'm sorry. So segmentation. Think of segmentation is the movement, just like the way your clothes are being dried in a clothes dryer. They need to be mixed so that the hot air that's being blown, will be drying every single part, including the middle part. In the same token, these little pouches are areas, sections in the small intestine that needs to churn around in order that the brush border enzyme, remember that brush border enzymes are being secreted only on the walls of the small intestine. So if they are not going to be moving the inside, then the only thing that's going to receive the brush border enzyme will be the ones that are directly in contact with the wall. So the middle part, the middle section, the food that is in the middle section will remain undigested. And you don't want that to happen. So segmentation is very popular, or is actually one of the major movement after a meal. All right. Now, in between meals, peristalsis would increase, initiated by a rise in hormone which you call motilin in late intestinal phase about every 90 to 120 minutes. Each wave would start to push food distally. Okay, this is referred to as the migrating motor complex. Meals, remnants, like whatever is left over and undigested, bacteria, debris are moved towards the large intestine. The complete trip, the trip itself, from the duodenum to the ileum takes about only 2 hours. Very slow. So, when they reach the end of the ileum, they will, the food now, the chyme, will have to move through a sphincter, a valve, which you call the ileocecal valve. The ileocecal valve or the ileocecal sphincter relaxes and admits the chyme, the undigested chyme, into the large intestine. Okay, and this is when the gastroileal reflex would enhance the formation of segmentation in the ileum. Gastrin increases the motility of the ileum. Okay, the ileocecal valve flaps close when a chyme exerts backward pressure, preventing regurgitation into the ileum. So this is actually a one-way valve. All right. So this is actually a very good cheat sheet again, a table that I have included here just to help you easily gather your information and your thought on the control of intestinal motility and the functions of all of the different overview of the gastrointestinal tract, and pretty much compare from before the intestine. So from the mouth to the pharynx and the esophagus, which we have finished already, and now we are already in the small intestine. There you go. This is in a continuation. Small intestine, and it even brings us down to the large intestine. It will have the major functions, okay, and then the additional functions that are involved in the process. So we're finished with the small intestine. We're now into the large intestine. The large intestine is or has three unique features, which is very unique to itself only, that is not visible or even present in any other GI tract organ. First of all, it has what you call the taenia coli. These are three bands of longitudinal smooth muscle in the muscularis. Guys, this is your what do you call this? The taenia coli. There you go. That long band there is your Taenia coli. That's still Taenia coli. And you can see only one band, but you have one here. You have two at the back side. So pretty much these would pull the entire intestine into pockets like this. They will shear them up and it will appear like wrinkled up like this. And that's exactly why we have what you call the pocket-like sacs, which you call haustra. This is caused by the tone of the Taenia coli. And then you have epiploic appendages. Those are fat-like substances, pouches of the visceral peritoneum that up to now we don't know what the purpose is of the epiploic appendages. And you have subdivisions. You have, first of all, the cecum, which is the first part of the large intestine. This is immediately abutting the ileum. Okay. You have the appendix, which is a mass of lymphoid tissue, which is part of the mucosa-associated lymphoid tissue of the immune system. It is a bacterial storehouse capable of recolonizing the gut whenever it is necessary. It is actually twisted. It's actually its shape makes it susceptible to blockages. So the colon, okay, now has three segments: the ascending colon, okay, the transverse colon, the descending colon, and the sigmoid colon. That's four parts, all right? So the ascending colon is actually on the right side of the abdominal cavity. It goes up and it makes a 90-degree turn, and that 90-degree turn, that right angle turn, is actually what you call your hepatic flexure. It's hepatic flexure because it's right by, that flexure right there is right by the liver. Now it goes right through and becomes the transverse colon. And the transverse colon would go and make a right angle turn. And that right angle turn is what you call the splenic flexure or the left colic flexure. It is now that's now going to be the start of the descending colon. From the descending colon, it turns and curves into like an S shape. And that's what you call the sigmoid colon. It connects itself into the rectum, then the anal canal, finally the anal canal. Okay, I mentioned that already. So, the anal canal is the last segment of the large intestine that opens on the exterior. Okay, this is actually the end, is actually where your anus is. And it has two sphincters. It has the internal anal sphincter, which is made up of smooth muscle and therefore is involuntary. Okay. And the internal anal sphincter is this area here, this long area right here. This is made up of smooth muscle. And then you have the external anal sphincter. This is actually your external anal sphincter. And they are skeletal in nature. So, how are you going to look at the relationship of the gut, or rather the gastrointestinal tract, with the other components of the abdominal cavity? Well, first of all, guys, take note that not everything is actually loaded into the abdominal cavity. Some of them are retroperitoneal. By retroperitoneal, we mean they are outside of the peritoneum. For instance, let's take a look at the duodenum. This is the duodenum right there. Take note that the duodenum is behind the peritoneum. Can you see that green line right there? This is actually the peritoneum that covers the wall, the parietal peritoneum. And so the duodenum is so close to the back wall that the peritoneum goes over it, and therefore that makes it retroperitoneal. And you have also, well, some of the other retroperitoneal organs would be also your ascending colon and descending colon are retroperitoneal. Your kidneys, your pair of kidneys are also retroperitoneal. Now, The only part of the colon that is not retroperitoneal is your transverse colon. Okay? Except for the transverse colon and some of the sigmoid parts, the rest of the colon, the ascending, the descending, and parts of the sigmoid and the anus is actually retroperitoneal. Intraperitoneal regions are anchored to the posterior abdominal wall by mesentery, which you call the mesocolon. As a matter of fact, the mesocolon is very visible if you're going to be flipping the colon and looking through at the back of the transverse colon. You can see the mesocolon easily. Okay, so here is the transverse mesocolon that I'm talking about. Okay, you flip it up and you could see it. Okay, and that's your greater omentum. It is connecting the stomach to the transverse colon, and that's your stomach right there. This is the cut edge of your greater omentum, cut in order for you to see the relationship of the other parts of the gut, the distal gut, okay, to the stomach. So, a few of its homeostatic imbalances. One of them will be the proverbial appendicitis. This is actually acute inflammation of the appendix and usually results from a blockage by feces that traps infectious bacteria. Okay, very common among children and adolescents. Okay, and pretty much if they rupture, they can cause what you call peritonitis. The symptoms of this will be pain around the umbilical cord moving to the right lower abdominal quadrant, loss of appetite, nausea, and vomiting. Okay, a lot of people go through it with just a simple appendectomy, a surgical removal of the appendix. So the bacterial flora of the colon usually is made up of more than 1,000 different types of bacteria. These bacteria outnumber our own cells 10 to 1. Wonderful. They enter from the small intestine or the anus to colonize the colon. The function would be for fermenting the fecal matter, okay, the undigested carbohydrates and mucin, and releasing very irritating acids and gas, about 500 ml a day. And also for synthesis of vitamins. They synthesize B complex and some vitamin K that's needed by the liver to produce the clotting factor. And they keep the bacteria, these good bacteria, keep the pathogenic bacteria in check. They are the reasons why the pathogenic bacteria are not killing us. The beneficial bacteria outnumbers them and suppresses the proliferation of the pathogenic bacteria. Okay? The immune system would destroy any bacteria that would try to breach the mucosal barrier. So the epithelial cells recruit dendritic cells to the mucosa to sample microbial antigens and present to the T cells of the mucosa associated lymphoid tissue. And thus, they trigger the production of antibodies that would be restricting these microbes. So the gut bacteria pretty much is very helpful, and there's mounting evidence that supports the findings and the kinds and proportions of gut bacteria that they can actually how they can actually influence our health, influence our body weight, our susceptibility to virus diseases, our moods even, and pretty much by manipulating the gut bacteria, it may become a routine healthcare strategy in the future. It is one of the newest endeavor in the study of the human health, studying the gut bacteria. So, there are some antibiotic associated diarrhea and accounts for about 14,000 deaths every year. When people take in too much antibiotic for a long time, but probably because it's really necessary because they're very sick, they are most likely going to affect also the uh, non-pathogenic bacteria that is resident of the gut. And one that is most difficult is that when these non-pathogenic bacteria would dwindle down, you have one very bad bacteria which you call Clostridium difficile. It is an anaerobic bacterium that many of us carry in our intestine, and pretty much will be the most common cause of this particular homeostatic imbalance. When other bacteria are wiped out by the antibiotics, these bacteria, the Clostridium difficile, can flourish and can cause pseudomembranous colitis or inflammation of the colon. This may lead to perforation of the bowel, okay, the colon itself, and sepsis. Now, C. difficile infections are very resistant. That's the bad part. They're very resistant to many antibiotics, and they are very difficult to kill. And pretty much the only treatment that works here is actually fecal transplants to replace the healthy bacteria that to suppress again the Clostridium difficile. Because if you killed the good bacteria, you need to replenish them, and therefore fecal transplants are actually one of the newest trend in regenerating your good bacteria. That doesn't sound good because you're going to have fecal transplants, and I'm not really quite sure clinically how that thing is going to work. If the doctors are going to get some bowel from other person and then transplant it into your colon. Oh, all right. So let's take a look at the digestive processes in the large intestine. Okay. Pretty much, guys, the residue remains in the large intestine, which is undigested material, and it remains there for between 12 to 24 hours. There's no food breakdown that occur here, okay, except when the bacteria would be digesting them. Vitamins are made there by the bacterial flora. Water, electrolytes, and sodium and chloride, which means a salt, are actually reclaimed in the area. Pretty much the major function really of the intestine really is to expel the feces to the anus for defecation. So the large intestine is important for our comfort, but it's not really essential for life. As a matter of fact, people can have the entire large intestine removed, and pretty much the terminal ileum can be brought out through the abdominal wall in a procedure which you call ileostomy. And it's not going to be connected to a bag that will be collecting the undigested material. So, what kind of movements will you find in the large intestine that is part of the digestive process? Well, you have what you call haustral contraction. Most of the contractions of the colons are pretty much when the haustra is sequentially contracting in response to distension. These are very slow segmenting movements, which is pretty much like churning movement, mostly in the in ascending and in the transverse colon. The gastrocolic reflex pretty much is initiated by the presence of food in the stomach. This is actually a reflex where we want to go to the bathroom and do a number 2. And it is initiated by the presence of food in the stomach. So when you just ate a little bit, all of a sudden you feel like you want to go to the bathroom, okay? Because you're now experiencing the gastrocolic, not gastroileal, but gastrocolic reflex. It results in mass movements, slow, powerful peristaltic waves that are activated about 3 to 4 times a day. And that's actually helping us get into mass emptying. The descending colon and the sigmoid colon would act as a storage reservoir. So mass peristalsis, after the mass, let's go back there, after this mass movement, okay, or mass peristalsis, from the middle of the transverse colon, the content of the large intestine from the middle of the transverse colon all the way distally is really going to be fully emptied out. on a regular basis by these mass movements. Okay? So low fiber diet can narrow colon and can pretty much cause strong contractions that increase pressure on the walls. And this pressure along the walls can cause indiverticula or herniation of the mucosa, which can result in diverticulosis, which is the presence of diverticula in the sigmoid colon and affects about more than half of the people, more importantly, more than 70 years of age. Diverticulitis is actually the inflamed diverticula that may rupture and leak into the peritoneal cavity and could be life threatening if it will not be contained. All right. And this is very difficult because the person has started to do this and it has developed over a long period of time because of diet. People who actually have a very low fiber diet, who loves meat but would not be favoring eating uh, plant products or vegetables, would actually be prone to diverticulitis. Irritable bowel syndrome is pretty much a functional gastrointestinal disorder. Symptoms will be recurring abdominal pain, stool changes, bloating, flatulence, nausea, and depression. And stress is a very common precipitating factor of IBS. And stress management is very important in this treatment. Okay, so let's take a look at the defecation reflex. Okay, first of all, the feces moves into and distends the rectum. You're now pretty much like getting a call that you need to really like empty your colon. It distends the rectum, stimulating the stretch receptors there. The receptors transmit the signals along the afferent fibers to the spinal cord neurons. Then the spinal reflex is initiated in which the parasympathetic motor efferent fibers would stimulate contraction of the rectum and the sigmoid colon, the relaxation of the internal as well as the relaxation of the internal and the external sphincters of the colon. Then, if it is convenient to defecate, voluntary neurons are now going to be inhibited, allowing the external anal sphincter to relax so that feces will pass. So, what is diarrhea? Diarrhea refers to an imbalance causing watery stools. Results when large intestine does not have sufficient time to absorb the remaining water. The cause would include irritation of the colon by bacteria, okay, or prolonged diarrhea may result in, actually it's caused by bacteria, or really this is true, jostling around of the digestive viscera, most especially for people who are marathon runners and when they are really running for a long period of time. Prolonged diarrhea may result in dehydration and electrolyte imbalance, and acidosis and loss of potassium. Now, constipation can occur when food remains in the colon for extended periods of time and too much water is absorbed. The stool becomes hard and very difficult to pass and may result from because of insufficient fiber or fluid in the diet, improper bowel habits, or lack of exercise, or abuse of laxative.